Yes,
Ah,
yes,
so
yes.
good morning, everybody, and everybody has a happy week ahead. Today we will discuss about Honeywell, one of the reputed manufacturer. Last 2 week we have discussed Emerson and Yokogawa. Every time you can see some change, and later on we will compare the systems, and then I will discuss it. When we have to compare all three systems, uh, what are the uh, core features of each one that we'll discuss. As far as the user is concerned, based on our requirement, how we select the system, that part also we'll discuss. But today we'll understand, or maybe may not possible cover into today, but tomorrow definitely we'll cover both the part, plant installation and actual hardware, right? So without taking much time, I'm just going ahead with the next slides. Uh, you can see here automation systems trend in the early 60s. PLCs were there, then 80s DCS introduced. At the same time, after 10 years, PC based control came in the picture for short duration. But each system has a core controller features. Like a PLC has a sequential control, which replaced the earlier our wired relays. Mechanical devices, electromechanical devices were replaced. Even hard wiring was replaced. It converted into programming by PLC. That was the biggest advantage for automation systems in the 60s, because you have not seen the relay type of interlock operation we have seen. So what are the actual benefits received for operation maintenance point of view, or we can say reliability of the production systems. So anyway, then DCS means what I want to tell you, PLC is for sequential control, DCS is for DCS controllers are for closed loop control, PID control. And that is what when the system is replaced, earlier we have a pneumatic control. Somehow we have analog control also, but most of the plants in the 70s were pneumatic controllers, pneumatic transmitter, everything was a pneumatic. Then as a cost was a DCS even was very very costly, small companies cannot afford. So new solution came during that time between 85 to 90, PC based control. So you can use as your own PC for controlling. But that was for a short duration, but it was not for critical operation of the plant, like power plant, refineries, chemicals, critical chemicals, fertilizers. They were not dependent, because that type of a system were only for generating your database and reports. PC is used only for collecting the information from the controller and put it into the database, because that controller don't have memory earlier days, much memory. So that was the advantage when PC based control came. Then a new system introduced in the 1995, supervisory control and data acquisition. And that was basically biggest advantage for uh, we can say logistic operations, especially initially it was introduced for power sector, electrical uh, distribution plant, when they distribute the systems to various locations like grids. So for that purpose, this has really benefited lot, and still we enjoying the benefit globally. Similarly, water distribution network, even in certain plants, your product is on the conveyor belt. It's coming from long distance, especially for steel plant mines, where 10 kilometers or 15 kilometers long conveyor belts are, and that is routed through very remote area, like for dense forest and all. So there these systems initially was introduced, means water distribution, electricity distribution, and then lastly it was started using in the gas distribution, oil and gas. You can see the offshore and onshore platforms, where raw oil is coming to the processing plant on the onshore, and there it is a process. And then later on you can see the pipeline network across the all refineries. Even customers are getting through pipeline now gas, like domestic gas also. I'm talking about the industrial processing plants. So oil and gas is the fourth application for the very important application used in the SCADA systems. So the SCADA system is for remote or long distance material transport. The material may be oil, gas, anything, water, electricity. Then fourth system is a safety instrumented system. Basically, this system is for we can say critical plants. Yesterday, when I was discussing, but I skipped that session, that particular part, emergency shutdown system, safety systems. This is a special type of a hardware, triple redundant hardware. We are always talking about dual redundancy, but in safety system, it is as per certification guidelines from seal and TUE. These are the certified in the your safety system. They they have a very stringent guidelines, very robust systems as far as hardware is concerned, software is concerned, and even we can say the installation at a very rugged, very harsh environment. So construction manufacturing is also point of view. So these systems are basically for critical operation of the plant, which are coming under zone 1, sorry, zone 0, zone 1, like that, or high pressure, high temperature, hazardous gases, inflammable gases. There these systems are must. And lastly, autonomous automation system. This is introduced recently in the 2020s. Now we are talking about autonomous automation systems. Means your systems are autonomous. Autonomous means, autonomy means your earlier systems are uh, geographically, you can see plant and nearby control room. So systems are within the plant or at the center of the plant to access the all your devices, controlling devices or process equipment operation should be easy for operating staff and maintenance staff. So your system is not getting communicated outside, and even your plant people, even in the in charges of plants, are not getting the information out from that automation system. But now autonomous means, autonomy means your system is now access remotely. Either we can say your people, experts, or your senior people, decision makers, director, chairman, they can get the certain business information directly on their remote devices, like maybe your mobile, laptops, iPads, etc. So, or if now we are talking about autonomous main benefit. See, the system is accessed by your, for example, this is a Honeywell system. So Honeywell team can access your system from their experts locations where their expert team is sitting, and then they can guide you for maintenance, for optimizing the process. And so what happens, no need to wait for their uh, visit, which require 1 week or maybe 15 days. It is required certain cases. If they are coming from abroad, it is again lengthy process. So now autonomous gives the benefit for your increasing the productivity, production increase, your real time optimization of the process, as well as maintenance is also real time. So that benefits to your profit, as well as it reduces the emission, which uh, which is because of your uh, improper setting of the operating parameters, or not with the in we can say your calibrate instruments are not properly calibrated, or maybe due to it is not working. So there are many reasons for hampering your environment or your productivity, or the equipment unnecessary overheated, like that. So many benefits are coming out of autonomous automation system. We'll discuss it later on, what is the architecture. But in this slide, I'm highlighting you are in the age of autonomous automation system. That's all. Means your this DCS PLC systems are you are accessing from remotely by your uh, manufacturer or your experts across. Suppose RCF has 5 locations plants, and their expert team is sitting in the chamber, and from there they can access, for example, Orissa there are 2 plants, for Alibag there is a plant, or maybe some other location in the north there is a plant, or maybe in the another location in the south there is a plant. So you need not to have experts at each locations. You understand? So this is the what benefit, and it is a real time. So this is the what automation new trend has came, and is the remote monitoring and expert advice through cloud connectivity. So this slide I have already discussed what is the DCS and all. So I'm going ahead. This also I have discussed. This also I have discussed. So I'm coming to the straight way to the Honeywell system. What we have used in our plants, and in general, these are all repeated systems globally. So Honeywell, we as a RCF, we have used TDC 3000 is the older version, or we can say very popular system in the 90s, 80 to 90 we can say. Then they introduced for short period total plant solution, TPS. So this TPS was a slightly uh, we can say this is a totally proprietary system. TDC 3000 is a proprietary system, this one. Then TPS is a little bit for we can say operator stations. We started using PCs, Dell PCs. So that was the advantage in TPS. And then they launched Experian a brand with various versions of a controller. Initially, they introduced C200 controller, then they came with the C300 controller, and same C300 controller is the latest with the software versions changing after 2 years. Means version software they are changing. Otherwise, controller is a name is same. So, what we are going to discuss today is a Honeywell C300 controller, right? Mm. Remaining Yokogawa, Emerson we discuss. Moore also we have not discussed. Honeywell Invensys, which has been taken over by now another group. So Moore is also now taken over by Siemens. So there are various systems. However, Honeywell, Yokogawa, Emerson remains as it is branded systems. Comparison we'll discuss later on. So we are discussing a Honeywell Experion journey. We are not going back. See, they introduced in the 1988 process manager IOs. That was a change. But Experion brand actually they introduced in 2003, and this the migration of older systems means TDC 3000 or TPS, as I told old version, they started integrating in 2004. Means you can integrate your old IOs with the new controller. That is what a migration or integration. Uh, so when you are migrating to new, you need not to absolute the older one. So each manufacturers, when they introduce new, they take care that your old IOs, plant IOs can be integrated. So they started integrating old IOs here, and then 2006 actually R300 process release means just develop, but it was not released to the process. But July 26, after 6 months or 7 months, they launched the system for the industry. July 2006. R300 is their software brand. Revision 300 for C300. So this is what system. So you can see the pictures. PMIOs means these are the IOs rack, and you can see various cards here in the rack. However, in the C200 controller, you can see is the Rockwell controller. Basically, was, for short period, Honeywell and Rockwell has a uh, understanding, business understanding, and they design Rockwell design control for Honeywell. So you can see the C200 is the earlier version in the uh, Experion brand, C200 for short period. And you can see here uh, power supplies, and these are controller, and these are various IO cards. So that type of like a PLC type rack was introduced. Actually, it's a PLC looks like, but slightly for PID control and all they introduce, especially for Honeywell. But immediately they launched C3 Series C controller, and they named C300 controller, and they named Series C, and that was a major change in the controller. You see here, what is the major change? First of all, they are on the no rack. They are, you can see this is the water controller card. This one, so that is not on a rack. That is on a plain back plane. You can see. I will show the picture. So the main advantage of this type of installation is there is no heat. Earlier in the rack, you can say here you can see the cards are continuously running, so heat dissipation, even though we maintain the air condition, but sometimes though the location where air condition is not properly maintained, the heat across these cards reduces the life of electronics on the card, and that way your cards get malfunctioning. You have to replace the cards. However, Honeywell came first time with this type of architecture where the cards have a sufficient isolated from the, there is no rack. I will show you. So you can see IOs and controller families optimized for customer requirement. And see, suppose in the rack there we need only 5 cards, and remaining slots remains idle. So in this card, this type of a series C, you can have a actual required cards. So no rack is required for this, and no spare slot type of a concept. Uh, they, so that is why it is written here, input output and controller families optimized for customer requirement, as per customer requirement. So I will show you the actual system cards, and then I will come to the actual architecture. So you can see here, see here C200 controller picture is like this. This is a power supply card, this one. These are controllers, IO cards like this. While Experion system, uh, total system with the C200 controller, means see, these are C200 controller, but these are redundant controller. This one and this redundant. IO network, IO network. This is a non-redundant controller. No redundancy on this controller. So physically, you can see there are two separate racks put on the supervisory fault tolerant network or control net or Ethernet. There were options, and these are redundant IOs here. IO only, no controller here. And this is IO network. So that type of architecture was there, and these are the workstation server. So you can see here the old systems of Honeywell, Honeywell dedicated controllers, PLC. This is a PLC. This is a controller. Honeywell UDC, Modicon PLC, Allen Bradley PLC, TD6000 data highway. So all connectivity is possible of their own families, Honeywell family controllers. And then finally you can put on the LAN, Ethernet. Mm. When we are talking about application or integration of old system, you can see here old system. I'm coming from the top. This is the HMI web operator and maintenance stations. These is Experion workstations like this. You see here the workstation type. They change the this 4 windows, 4 workstation you can see on single place. So operators need not to move the head here and there. So that type of a concept they started. They changed the furniture ergonomic type, and you see here the screens and keyboard here, and sufficient place for operating people. Old station is a GUS, they call it a global user station. This one is a GUS. And these are, as I told, Dell work server PCs, server grade machines. redundant integration nodes. And you see this is a C200 controller redundant. Old IOs, process manager IOs you can connect. And this is one of the application, PLC application is shown here. Pump compressors like this. Is a boiler application you can have. HPM IOs, then a fail-safe controller is a safety system for a boiler and this. So this is what they in this slide it is showing that integrating older systems, newer systems with the systems. So this is what we have used in the ammonia plant with us, C200 controller redundant and fail-safe system. That is what is SIS, safety instrumentation system here. This is as I told, uh, seal category. It is seal 3, seal 1, seal 2, seal 3 is the highest category. 3 is a triple redundant systems, controller systems here for operation of a compressor, because compressor is very critical. Some critical parameters of the compressor, pressure, anti-surge, vibrations, all these are these interlocks are run parallelly on this also. And this is for serial interface gateway here, redundant server. So this is their Honeywell control network name, fault tolerant Ethernet network. So as I told, the speed is always changing. That was a 1000 Mbps. Now it is a Gbps. Workstation also look is changing. Mm. Though this picture shows the how redundancy in the servers, redundancy in the controller, redundancy in the IO cards. We have already shown on the immersion also, Yokogawa also. Here also they have controller redundancy, but server also get redundant because your system database is coming to the primary server first from the both the controllers, and then database checkpoints are automatically transferred on the backup server. And always your primary server is configured for real-time operating people screens, operator stations. These are operator stations, so this way it is operated. When this fails, then this supports here for both data coming here. So you see your primary network, secondary network, as well as this way servers are configured for data checkpoints. This is one card, that is a foundation filbus card. Earlier system was a card was on the rack mounted. Now new series C card will be look is like this. This way it is fixed on this. There are screws on this, and just you have to replace. No wire, nothing. And from this plane, all your networking is done with other controllers and other devices. I will show you later on. So as far as a Honeywell system is concerned, this is the look. As I told, it is a series C system, and you see here something different. You see here various cards are there, the IO cards here. Here you can see the controller is here, some firewalls, power supplies, firewall controller like this, it is there. Then IO cards are here. You see the number of wires are coming, and there are each card, though it is a redundant here, these are redundant here, but it is isolated. Means there is a sufficient space for heat dissipation. So in this type of architecture, 5 to 20% space reduction over the competitors. Means unnecessary we have to because separate rack for IO, separate for controller, power supply separate. Instead of on single rack, you can put each card like this. You can see your controller two here. Then again another controller. Means if you have two controllers in this plant, redundancy is there, firewall redundancy here, and power supply redundancy. This is the primary power supply, secondary power supply, primary firewall, secondary firewall, primary controller, secondary controller, like this. And these are AI, ODI, like that. IOs are there. So easy installation and maintenance, improved thermal management. Means I just explained heat dissipation for a greater IO reliability. So life, suppose normal life is a 5 years. So definitely you can use the system for next 2 years, also 7 years. Ideally, if you are really maintaining system as far as a dust, climate, I mean clean air inside, temperature maintenance. Then it goes more than 10 also. So this slide just is different, but remote monitoring services through cloud has given a major advantage, but at the same time the systems are very risky as far as the cyber threat is concerned. So Honeywell is taking care of that, as I told, firewall act inside the system. But when system go connected to the cloud through cloud to their expert system, then because we are using internet for that, or cloud is used. So you can see here, this is our host system. From here, firewall, customer plan network, and again another firewall, then internet through cloud, and then firewall at Honeywell, Honeywell center here, remote center. So they have encrypted links, and because of encrypted link, like we say 128-bit encryption, or it is also more than that. So through that, it is very difficult to the s- uh, cyber, means it is a safe as far as uh, using of cloud connectivity is concerned. This is a slide showing the how old systems are integrated. Old IOs are integrated with the series C controller. This is a new controller. These are the old IOs, and that I was on IO link. That is a communication protocol for input. Or is actually it is a Modbus protocol, but Honeywell has given the name is IO link, input output link, which is a dual redundant. So, and these are the C200 controllers IOs. So, and they are on the fault tolerant Ethernet FTE. So both can be connected here. You can see. So you can have a common interlock here for both, maybe input from here and output you are processing through the C200 IOs. That is also possible. Interlock. This is what screenshot here. Again, I will go back for the plant systems. Let me finish actual hardware. So you can see here packaging overview, how it is looks like the IOs. Series C terms is for the new styling for the family of controller and IO. Series C. This is a new styling. This is what Series C they say. This is actual controller on the install on this. Space efficient design. Design vertically. No electronic card files. These are less than 30% reduction compared to the equivalent earlier. Means if you see HPM is this types of IOs. I will show you IOs. HPM is this. Sorry. Oh, here HPM. These types of IOs. These are rack type. It is called HPM IOs. These are rack type, and it requires more space. And if you go for Series C, it is reducing the space here. Combines IO processor and field termination into the assembly. This is something different. Means they have taken care field termination into one assembly. Means on wherever your this plane the card is installed now, on that field terminal, means there is a separate, earlier it was a FTA was a separate field terminal. I cards very different field terminal, FTA they say. FTA means field terminal accessories. That was basically for isolation, signal isolation and signal repetitions, means duplication. So now what they have done, eh, here inside the backplane, that electronics is there, and they are to duplicate the signal, and even provides optically isolations or galvanic isolation. So that is what a point here. So the controller is here. You can see the picture display here, power and status. That's all. And here control network, FTA, FTE, bay control network. So the status of the controller you will get it here. This is a Honeywell controller, and this is a screw for fitting. That's all. So the Honeywell C300 controller provides a powerful and robust control for the Experion platform. C300 joins the C200 and the application control environment node in the operating. Honeywell's field proven determine, actually these are the Honeywell's terminology as well as older controller. Honeywell has a control execution environment and application controller means this is for AC and CE. These are for these are the softwares basically to create PID loops and all. So I will show you later on ACs and CE. The CE provides a supervisory control execution. So this software provides supervisory control and scheduling environment. Control strategies are configured, as I told, and loaded through control builder. This is the tool, control builder, and easy. This control builder is an easy and initiative engineering tools means it is a if you see this tool is like yesterday we see the graphic builder control in the Yokogawa, so even we have seen in the immersion also control studios. These are the names. However, here they say control builder. The C300 controller hardware offers unique space saving installations and maintenance benefits consistent with its innovative Series C form factor. The C300 is optionally redundant and requiring no additional hardware other than the identical second hardware module. So this is the what the actual controller. This is a single control. If they give you the redundancy also. So actually, vertical design is like this. This is the IOs, more uniform heat management, more efficient field wiring. So you can see reduce the hot spaces, top and bottom wiring entry, more natural terminations, no severe wire bends. So directly you can have natural wiring. Modular approach, removable terminal blocks, integral shields termination. So all benefits are there with the systems. So this is the what how the system looks like even it is in the plant. uh, Series C IOs are also there. Series C Filbus card is also there. Controller is there. Series C control firewall is there for protection of the, as I told, unauthorized entry, as well as some alarm scheduling and power system, power supply card. So power supply card, firewall card, controller card, Filbus card, and IO cards, analog input, all are in the series. Related deliverables, new FT bridged firmware that supports C300 integration to selected Series A IOs. So FT is also standard their bridge. Mm. This is a control network. So if you see the controller, uh, their features, as I told, display communication here, display panel. Peer-to-peer communication means A and B. IO link is here. IO link 2 is here like this. IO link, peer-to-peer communication, display communication, entire thing is I will show you details here. IOTA terminations, IOTA available for all IOTAs, same cable used for all IOTAs, input output termination assembly. As we are talking about, this is what all cables, termination cables. So if you see the IO cards, this is what terminations are coming here. This is IO card. Hmm. So now I will show the plant system. We have various plants. I will take a one example. As I told, old IOs is a PM IOs in our urea plant. Same IOs are only we change the controller here. So old IOs racks on this new card. So this is series C. Only we change the controller. So controller is there and which is redundant here. This network is called, as I told, IO network, IO link. This is IO link. So input output module, control firewall, FTE, Ethernet switch, operator stations. So you can see here these are operator stations. This is FTE, control network, fault tolerant Ethernet. 1 and 2 means A and B means redundant. One is the primary, another is secondary. Then CF1 and CF2. CF1 and the control firewall hardware. These two, and the power supply as not shown, but it is required, that is also there. And this is actual primary controller and this is secondary controller. So you can see here directly your IO link wires are coming here from here, and FT cables are going from the top to this, and this is all old IOs. Process manager input output files means racks. This Honeywell say file instead of rack. So file 1, file 2, file 3, file 4, and file 5. That much I was we are using, integrating with a new controller, series C controller, and we get advantage here: workstations, Ethernet speed, security, and controller. So that way, integration is the best example instead of Honeywell product slides. This is actually what we have used. Similarly, we have, I'm showing going back because I skipped here. This is what system I have shown now. One more system is there. What is that? Methanol plant. You see here. There also we have PMIOs, IO link, C300 controller, redundant, control firewall, which is also series C. Then another controller. These are IO links, redundant controller, and this is on Ethernet switch. This is primary, secondary Ethernet switch, normal switches, and the system is on the server. Honeywell for workstation, there is a server A, server B, server C. Normally we say workstations, operator station, but in Honeywell terminology or their nomenclature, they say server to the stations. So we will use the name server A, server B, server C. That's all. This is another section of the plant, rag A, rag, but there we have a Yokogawa system here. So therefore, it is not much mention IO link and all this. Mm. So this I have explained. I'm going ahead with the actual plant system now. So ammonia plant, we have a system, and actually I will show you the how Experion system is used there. As briefly, I'm telling you, ammonia is a very important raw material for a downstream plants in the fertilizers and even the other chemicals like urea plant chemical. I mean, I'm talking about the fertilizers, all our ureas and your complex fertilizers, NPK, uh, different configuration, ammonia is required. Then methanol plant, nitric acid plant, and as also sulfuric acid, all other our chemicals, industrial chemical plant also ammonia is required. So it is our, we can say ammonia is a very important um raw material which is required. Without ammonia we cannot run the fertilizer or any chemical industry. Now, in the ammonia, for manufacturing the ammonia, we require a natural gas that is coming from ONGC or GAIL, Gas Authority of India, as well as Reliance. So there are different sources and different types of gases are available. Now LNG is also available, but the costing is different for each type of gases. Even we import also sometimes. So this is called the spot prices of the gases. That is different terminology for using of the gases, uh, and that governed by ministry government. So natural gas is a main source, and there we have a reactor, HDS reactor, which removes the bulk sulfur from this hydrogenation desulfurization reactor, and then the gas is coming to the primary reformer. This reforming mix with the steam and reform this one. So is a high temperature, pressure, high pressure, and then This hydrogen, CO and CO2s are coming out. In the shift converter, CO is converted into CO2. Again, this CO is converted to CO2. So in the third section is a MDEA, methyl dimethyl amine absorption. So CO2 here removed, and this CO2 is used for manufacturing of urea, because for manufacturing of urea, CO2 and ammonia both are reacting together. So one product coming out of this process is a CO2, which is separated and is used for other plant for manufacturing of urea. Then this goes to the methanation, and this methanation means whatever balance CO and CO2 is still in the process, again in the converted into methane, methanation. And synthesis gas, where we call here converter. Synthesis gas means here we call it a synthesis gas where methane is there, which is converted into ammonia in the converter, and then finally it goes to the refrigeration. So here ammonia is managed. It is the refrigeration, separation of ammonia and converted reactant goes back to the converter here, recycle, and here you get ammonia, which goes to the urea and storage also. So this is the what liquid ammonia product, storage as well as use for the plants. So this is what a very critical process that requires high pressure, high temperature, especially synthesis gas compressors are very, very important here. So ammonia condenser stripper automation, that was one of the section I have taken to demonstrate how DCS system, Honeywell DCS is installed. So what is the function of stripper? Medium pressure condenser stripper. We recently done the modification for energy optimization. So you can see that what is this ammonia condenser stripper means, process condensate from the separator is coming to this section, this equipment, and for that medium pressure steam is used. See, from condensate we have to separate some gases. So what happen, from this condensate using steam, whatever, then what you are getting output here, process steam, because this steam is there, steam is coming out here, but recycle gases to reform. I mean, so he's this using this steam, the gases are coming out from the condensate is taken here, and in the condenser stripper demineralized water is coming out here, and this water goes for further usage, like cooling towers and boiler. The water is required, dm water, which is very pure water for process, which is required. So what is happening here, we are recycling the gases as well as we are getting water here, right? Means from the condensate whatever gases, our process gases are there, these are we are recycling back. So accordingly our process uh, uh, production increases, and this water also used for further this. So this is the actual equipment. So before, earlier what was LP condenser stripper, now it is coming medium pressure condenser stripper, and we what is again 0.2 million kilocalories per metric ton energy saving is there. So that is the benefit of this stripper, and this is actually what equipment looks like. Processing unit operation is here. This is a condensate stripper. So you can see the pipelines from here, condensates recycled, medium pressure lines are down or in between here. Product, as I told, condensate stripping from the top like this. It is there, and all it is a high temperature, so it is insulated. So this is about condenser stripper. So this is the ground level of this. This is the stripper where some students are there, and it is demonstrated what are the instrumentations here. As you know, the safety guidelines. You have to use your helmets when you are. You have to use the shoes, safety shoes. All this is there. These are the students like you. So this section, PI and ID, piping and flow diagrams. You can see here piping and instrumentation drawings. You can see here of this stripper. This is a stripper picture symbol, and you see here at the bottom we are taking demineralized water, and this is a medium pressure steam we are introducing here. Here you can see, and the from the top we are this actually this is a recycle. We have a MP condensate that is also introduced from the top, and this way you can see here. Uh, these are the instrumentation here. I will show you the actual DCS graphics. This is a process condensate stripper. Here you see the DCS graphic look. This is a steam line, medium pressure steam line. This is a process condensate we are taking here from top, and finally you can see the steam is going from here and it is taken back with the, but this steam is carrying recycled glasses here because of in the stripping process. And this is what graphic showing the present liquid level dm water, demineralized water here. This, and for that here instrumentation is there. Control lic is there, level indicating control for controlling the level in this tank. Then this is a steam line which has a control wall here, and these are other instrumentation for controlling the steam flow. This is what it is there. Then outside you can see the temperature, pressure of the recycled back steam. So this is the what section uh, we will describe or show you how Honeywell DCS is installed. So, but you see the Honeywell graphics, the faceplate of LIC, means I'm talking about LIC 130. This is a process condenser stripper. This level. It, this is auto mode, operator mode. This is a, you can see the set value, output, like this. You can see the uh, set value, process value, and output. Three in the graphic for in the graphic way here. This is a set value. So just you see here the picture. MP steam is a 40 ATA is a unit. Uh, 37 to 38 kg pressure, temperature is 360 degree, and flow rate is 6 tons per hour. So this is the line, and this is the control wall. So you can see the orifice plate, flow control, steam flow control, orifice plate, transmitter FT, and this is in DCS FIC, and the output of this I2P, and this is the control wall. These are all isolation walls for wall maintenance. But here you can see here, this is a normal loop I2P and this control wall. But in between you can see the fuzzy loop, intrinsic shape loop is solenoid walls. In case this loop fail, this your safety system will, oh sorry, safety system will stop this wall, step shutdown or step closing of the wall. So that is what symbol indicates here. FGI, this is the safety system, and indicators for here, pressure indicator at downstream side. This is a what, flow wall, flow control wall. So this is a steam outlet, this is steam inlet. So this is the what critical loop in the condenser. So I will show the instrumentation here. So as I told, in this loop, this part orifice plate is here, which is in the red circle. Orifice plate installed for steam flow, this steam line. And from this orifice, you can see two tappings, upstream and downstream is taken down to the transmitter because the line is on top and at the height. And this is the transmitter which showing FT130. This is this, and your tappings and all your is down. You can see here. This is the signal cables going to the system through JBs. So in the controller, this faceplate is there. This F5C130 is inside this controller. This is what a picture of the controller. It resides in the controller when transmitter input is coming, right? Now I'm coming to the termination diagram and all. So this is a FT1301 transmitter. This cables coming to the JBS. JB number is a DCS 03. At 7 and 8 terminal it is connected. And then this is a multi-pair cable goes to the control room marshalling cabinet here. Same thing for output section from marshalling cabinet. JB SOV01 cable. These are for fuzzy logic. So solenoid valve JB is this SOV, and through this it is coming here. Fuzzy 1301 primary and redundant means I'm talking about this fuzzy, this 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 fuzzy. So this is the JB of the DCS. As the installation was a new, it is easy for you to now visualize it. X proof JB, and this you see the number of cables coming from various transmitters. This is what a multi-pair cable you can see going to the marshalling cabinet in the control room. Single cables in out. When you open this JB, you can see the termination. So you see individual terminals are coming like this, while multi-pair cables are going like this. You can see through this glands and all ferrules. You see the terminations, right? When junction box you open, it looks like this. So most of the times we are working here, and you see this drawings and all terminal numbers. So this is what I have shown. This is also FT I have shown, and the actual FT readings on DCS faceplate you can see here. The temperature 376. Because the plant was this was a new modification in project stage. So this is the wall controlling this without insulation. The insulation was there, so I taken a picture during that time. You see here, this is the wall with a hard positioner in this, and these are all isolation walls here. You can see this side isolation, and when this is what the wall is before, and now after insulation, you see wall looks like this is insulated now. This is the hard positioner reading on the control wall, and same on the DCS faceplate, DCS workstations. So these are solenoid walls for fuzzy operation, safety operation point of view. So actually, these are very important part, but time is very short. We will continue next session. I think that will be better because these are very rare pictures, and you will come to know what are the instrumentations in the DCS loop. So I think madam has suggested 12:15, and I think there is a 1 minute for you, or I think it is a normal 15 only. But if you have any question, you can ask me. Hello,
Yes,
hello.
sir.
Oh, echo is there, I think. Okay. So as I told you, uh, whatever questions after the total systems coverage, you can we can discuss, and we'll answer that questions in the separate session. No problem. I know you are hectic. I think with this I close this for today. Thank you very much.
Yes, sir. Yes,
Hello.
sir. Thank you very much. We
We'll
will meet
continue.
tomorrow.
Right. Hello.
We will meet tomorrow
Yeah, yeah.
for the remaining.
Timing you just suggest me. Accordingly, I will plan. Right.
Okay, okay, sir. Okay, thank you.
Okay. Thank you. Thank you, madam. Thank you.
Busa.